Now this illustration deals with large equipment in accordance with 110.33A1. Now just as a reminder, if the voltage is less than 1,000 volts, then remember there were two conditions that had to be present for it to be considered large equipment. You must have a continuous bus over 1,200 amps, and the equipment has to be over 6 foot wide. And if we had, say, 3 mains and a switch gear, or maybe a switchboard, whatever, and you had one section with a bus 900 amps, you had a second section with a bus 900 amps, and a third section with a bus at 900 amps, but the bus wasn't continuous except in each individual section, then you would add those 3 900 amp mains together, which would be approximately 2,700 amps, and that would be considered large equipment now by the NEC edition of the 2020 NEC edition, so to speak. Now, that wasn't so in the 2017. It had to be a continuous bus, period, at 1,200 amps or more, and the equipment had to be over 6 foot wide with the change just mentioned in the 2020 NEC. But now when we get into large equipment, there's just one condition. The equipment has to be over 6 foot wide. It doesn't matter the size of the bus. Now we included 4 notes in this illustration that we hope will be very helpful to the viewer. And notice note 1, at least one entrance shall be required at each end of the switchboard or control panel. Where the equipment is over 6 foot wide in width is considered large equipment. Note 2, one entrance at each end shall not be required where the workspace is doubled or the location permits a continuous and unobstructed way of exit travel egress getting out of the area. Note 3, suitable means is required to be designed to guard bare or uninsulated or insulated parts more than 1,000 volts nominal, located adjacent at each entrance. Note 4, the electrical equipment over 6 foot wide now is considered large equipment when the voltage is over 1,000 volts. Now notice in the illustration, if we have access completely around that equipment, front, sides, and back, then we need a 24-inch way around the sides of that equipment to the back. Then the back would need the same clearances as the front if we could gain into energized or unenergized components. But any type components that wasn't energized or unenergized, then we would only need 30 inches by the code. And notice in this illustration, we have 2 exits. So we can enter and exit safely under electrical arc condition as shown in the illustration. We have a minimum width there of 2 foot and 6.5 foot on, around the sides of the equipment. Now, if you only had one door, then we would double the workspace based upon condition 1, 2, or 3. Condition 1 is kind of a little repetitious here, but the wall would be insulated, so we'd need 3 foot, but if we only had one door, you double that workspace and be 6 foot. If it was a grounded wall, condition 2 would take over, and it would be 3.5 foot, so we would double the workspace being 7 foot because of only one door. If there was equipment, opposite equipment, say in the front there, then we would need the clearance of whatever the table 110.34 call for, and you would double it. Now notice we would double the workspace based upon table 130.34. We would double the workspace based upon table 126A1 based upon conditions 1, 2, or 3. So make sure you realize that the workspace now is not from table 110.26A1, but is obtained from table 110.34A because the voltage is over 1,000 volts. You could only have, in most cases, condition 1, 2, or 3 at 3 foot, 3.5 foot, and 4 foot if the voltage was less than 1,000 volts. If it's over 1,000 volts, then remember, we have to go to the table 110.34A because those voltage levels there are 5, not 3, is listed in 110.26A1. So remember that, and this particular illustration is dealing with large equipment in accordance with NEC 110.33, A as in apple, 1.